This conference will now be recorded.
Very good morning to everyone. Whether it's audible online. Yes, online, whether it's audible.
Yes, it is
Yes,
audible
sir.
for me.
Yes, sir.
Thank you. So today here we have to take a demo session, right? It's a demo session for physical design. We are here today. We are present here for demo session of physical design. Today we are doing the demo session of physical design. And why physical design? First we will see why physical design. All right. So what is my today's agenda? Right. Today's agenda is demo session agenda is why or what is physical design? Right? What is physical design? What do we do in this? That is what the first thing I'm going to discuss. So first we will see what is IC. So how to design an IC. So what is the role of physical design engineers? That is what today's agenda. So next thing, right? About next I'm going to discuss about syllabus of physical design. What we are going to cover and what is the syllabus, right? And timings, timings of a course. Right? Next thing I'm going to discuss about last thing, right? Job opportunities. So where you can get the job opportunities. Right? So later I can take up your questions. What are the questions you have? So my today's agenda is to discuss these three aspects. So why and what physical design? So why we have to do physical design and what is the role of physical design
It is
engineers?
not audible over there. I'm not audible here.
Yes. So what is your query? Hello. Hello. Someone interrupted me in between. What is the query? Whether it's audible now properly? Is everyone
Yeah,
able
yeah,
to
now
Yeah,
hear
it's
it's
me?
audible.
audible.
Yes. Thank you.
Yes,
So
sir.
now, first, what is integrated circuit? IC. IC is called as integrated circuit. So this IC, right? This is whatever you're seeing is an IC, and everyone, I'm sure that everyone has seen the IC during your UG classes. So you have used few ICs. All right, this IC. So this IC is present. Whatever IC, what we want to see, right? It's already present inside here. Is whatever we are seeing is package, IC package. IC is packed with packaging along with packaging pins, but IC is very small. It is even in millimeter, right? You can see the entire structure here. This is the chip, what it's seeing, right? This much is chip size. So remaining thing is totally plastic and packaging pins. Right? Then what is present in this IC? Can anyone tell me what is present inside the IC? So in this IC, you have millions of transistors. This IC has millions of transistors. Millions of transistors in this small region. So then what is the size of transistor? The size of transistor is in nanometer. The size of transistor is in nanometer. It is nanometer scale. Nanometer cannot be seen through our eyes. We cannot see nanometer, right, through our eyes. It is very small. We can see only through complex microscopes. Then who is going to fabricate this IC? Who is going to fabricate IC? Where we fabricate this IC? What is a place called as? This IC is fabricated in a place called as foundry. Right? Foundry is going to fabricate this IC. So we have one of the example for foundry is like TSMC, Taiwan Semiconductor Manufacturing Corporation. So foundry is a place where the IC is fabricated, and this process of fabrication is totally chemically driven, forming a transistor, forming a source of a transistor, a drain of a transistor, right? Everything is chemically driven, and this foundry should be very clean, very neat, all right, and it should be well sophisticated. Minimum 500 to 1000 crores of investment required for this to establish a foundry. It should be even 1000 times cleaner and neater than your hospital operation theatre, because a small dust powder can cover hundreds of transistors, because transistor size is nanometer. So huge investment is required to open a foundry. And when any company, right, for example, you have some company, for example, you have a company called as Samsung, you have a company called as AMD, you have a company called as Intel. There is a different companies you have. If company wants to get fabricate their IC from the foundry, right, they have to invest a huge. It's not so easy. If they want to get fabricate their IC from the foundry, means they have to invest huge. Minimum they have to invest 5 crores to 10 crores. But when this IC comes to market, right? When this IC comes to market, for example, you take this Qualcomm is fabricating a mobile SoC, and this IC comes to the market, it will be not more than 2000 rupees. It will be not even more than 2000 rupees. So what is their investment? Investment is in the crores, but the cost of one IC, right? It is not even more than 2000 rupees. If they want to cover what is their investment, then how many number of IC they have to sell? They have to sell huge number of ICs. So they should never lose the market. If they lose the market, right, the company will lose a lot of things, lot of investment they are going to lose. If they should not lose the market, then IC should be having small size. This IC should occupy small size. It should be consuming less power. It should be operating with high speed. Right? High speed of operation is very important. High speed. IC should be designed with all the three aspects. If all the three are working properly, then only the IC will hit the market. Then only the foundry will get whatever they have invested, or else foundry will never get whatever they invested. They will lose whatever they have invested. right? So for when we talk about IC, right, we have two phases. When I talk about IC, all right, I have two phases. So one is fabrication. When I talk about IC, there is fabrication, fabricating IC. This fabrication, I already told you people, we are not going to do the fabrication. Who is going to do the fabrication? Who will do the fabrication? Fabrication is done in foundry. Right? The well established foundry, they are going to do the fabrication. First, you should be knowing the meaning of right. What is foundry? Then only you can understand. You should be knowing the meaning of foundry. Then only you can understand what is physical design. So foundry is the place where IC is fabricated. We are not going to fabricate. Then why engineers are recruited in the place of VLSI design? We have VLSI design. Why engineers are recruited? So we have millions of cells or millions of transistors in a small area. We have to integrate all these millions of cells in a small area to meet power and to meet what? Speed. Both we have to meet. So then we have to design, right? We have to design a complicated design. We have to design a IC. Design IC. So second important thing is designing an IC.
I think voice is not audible.
Yes. So while designing an IC, right? What are the steps we have? So designing an IC is done by using EDA tools. Designing IC is done by by using EDA tools. What is meaning of EDA tools? What is full form of that? Electronic design automation. Electronic design automation tools. So in your UG classes, whether you have used Xilinx, Xilinx is the electronic design automation tool for designing FPGA. Alright. Similarly, we have electronic design automation tools to design this ICs. Alright. We have EDA tools, right, from Cadence and Synopsys. And we have Cadence. And even some tools are from Mentor Graphics also. So we use electronic design automation tools like Synopsys, Cadence, and Mental Graphics to design an IC. So now, what is our role is we are not involved in fabrication. We are involved in designing an IC by using any of this tool. We can use either Synopsys tool, or industry may use what Cadence tool, or they may use Mental Graphics tools. By using these tools, we are designing an IC. So now you clearly understood, right? We are involved in designing an IC. We are not involved in fabricating IC. So then, what is the design steps? Where physical design comes? What is the role of physical design engineers? That is what I'm going to discuss next. That is called as a ASIC design flow. To understand this, we have to understand ASIC design flow. So, what is ASIC stands for? Can anyone tell me what is ASIC?
Application specific integrated circuit.
Yes, good, right? ASIC stands for application specific. ASIC stands for application specific integrated circuit. So the
Today
name
how
only
many
tells, right?
hours class?
Application specific. Yes, tell me. Please tell me what is your
Today
query.
how many hours class? Today how many hours class will be?
It will be for 2 hours, sir. 2 or 2.5 hours. 2 hours for discussion, and the remaining half an hour is for to answer your queries.
Okay.
Yes, thank you. Right. So the name only tells, right? Application specific, right? We are designing an IC which is for application specific. So I will design an IC for mobile phone application, right? SoC. It will use for only mobile phone application. I cannot use this for washing machine. So we are designing an IC for a specific purpose, right? That is called as application specific integrated circuit. So when I start with this IC, right? So what is when I start designing this IC, right? I have to follow this ASIC design flow. We'll start with what? ASIC design flow. So in ASIC design flow, first we start with the specification. First we start with the specification. Right? So what is specification? So the managers or the company owners, right? They will involve with their client and they will get what are all the functional blocks they want in IC. I want Ethernet module. I want PCI controller module. I want memory controller module. I want Wi-Fi module. I want Bluetooth module. In an IC, what are the modules you want? What are the circuits you want? Right? You will get all the information from your client. And what should be the area of IC? What should be the operating speed? What operating speed you expect? So what is the battery you are using, right? Or what should be the power consumption? So if your client tells that I'm using 3000 mAh battery, then you can estimate what should be the power of your IC, leakage power and dynamic power. So all these things, right, is collected from your vendor. That is called as what? IC specification. So after IC specification, right, next is you have to code this IC. You have to start implementing this IC. So you use for this implementing IC, right? For implementing this IC, you use RTL coding. RTL coding means it is Verilog or VHDL. We use Verilog or VHDL for defining a circuit. So can anyone tell me why we use RTL coding for defining circuit? Can you answer for me for this? So I think in UG classes, you people have used RTL coding, like Verilog or VLSI people have used. Why? For what purpose you have used? See, defining any circuit, right? If you want to define any circuit, defining from its structure is very difficult, but we can easily define through its behavior. So now if I ask the question to any student, draw the diagram of two input mux, how many will you draw? Internal structure by using gates. Hardly few. But if I ask the question, right, explain the operation of two input mux, how many will you answer? Explain the operation. Everyone can answer, right? What is the operation? When S is equal to 0, what is the operation? When S is equal to 0, Y is equal to what? I naught. Y is going to take what? I naught. When S is equal to 1, your Y is going to take what? I1. Simple behavior. Everyone can tell this behavior easily. So any circuit, right? Internal structure remembering is very difficult. You cannot remember the internal structure. But you can remember its behavior. What is the behavior? If I ask the same question for D flip-flop, tell me the internal structure. You cannot tell easily. Everyone cannot tell that. But if I ask, tell me the behavior of D flip-flop, you can easily tell the behavior. During the positive edge of clock, your Q is going to take what? D. If reset is 1, Q is always 0. You can easily tell the behavior. So I can use any coding, right, to capture this behavior of a circuit. To capture the behavior of a circuit, right, I can use any coding. So I can directly use like this, right? I can use if statements. If S equals 0, what is Y? Y is equal to what? I naught. Else means what? S is not equal to 0. S is 1. S means or then what is Y? Y is nothing but what? I1. I easily transform this behavior to the Verilog coding. So the role of a design engineer became very easy when they introduced RTL. There is Verilog and VHDL. The role of designer became very easy. Like he need not to implement internal structure. Just he can implement the behavior of a circuit. That's it. It's very easy. So for that purpose, what we do is we start with the design entry by using what? RTL coding. In RTL coding, we use either Verilog or VHDL. We use Verilog or VHDL. Generally, we use behavioral method for RTL coding. Behavioral means describe the behavior of a circuit by using if statements, case statements, procedural statements. We go with RTL coding. Now my design in the form of what? In its behavior, right? RTL coding is nothing but what? RTL coding is nothing but behavior of a circuit, not its internal structure. We have FSM method, finite state machine. We can even capture behavior of a complex circuit. It's in the Verilog program now. My design is in the Verilog program. So after writing the Verilog program, I have written the program for mux, two input mux. I have to verify this program is working properly or not. This whatever the RTL I have written, right? Whether it is working like two input mux or not, I have to verify it. What I will do, I apply what different inputs here. I will make S as 0, right? Y I naught, I1. I apply different inputs and I will find what is the output. When S is 0, I naught is 0, I1 is 0. What is the output? When S is 0, Y is going to take what? I naught. So output is 0. So you apply different inputs and you will identify what is the output. So for all the combination of inputs, whether you're getting proper output or not, you're going to verify. So this phase is called as a functional verification. Next step is functional verification. So what is functional verification? What is functional verification? Verifying the functionality of a design. Right? What is design? Design is nothing but RTL coding. We have entered the design through what? So verifying functionality of a design through by applying test cases. This is called as test cases. It's not I1, I0, right? Whatever you are applying this is called as test cases. Verifying functionality of a design by applying test cases. That is called as a functional verification. So functional verification is nothing but verifying the functionality of a design. Verifying functionality of a design is called as what? Functional verification. How do you verify? By applying what? Test cases. See, applying these test cases is very easy when the program is very simple. If it is complex, right? The applying test cases, all the test cases is very difficult. And handling the complex design is also very difficult. So to do functional verification, you have to learn system Verilog and you have to learn UVM. To do functional verification, you have to learn system Verilog and you have to learn what? UVM. So this is one of the job opportunity where you have. So one job opportunity is you can become RTL design engineer. You should be knowing Verilog VHDL properly, complete Verilog VHDL. You should be knowing about integrated circuits. You should be knowing about digital circuits. So to become functional verification engineer, you should be knowing system Verilog. You should be knowing UVM. What is UVM? Universal verification modeling or methodology. So you should be knowing that properly. Then you can become functional verification engineer. Now your design is in Verilog or VHDL form. It is in what form? It is in the behavioral form, correct? It is in the behavioral form. So your foundry cannot understand this behavioral form. Ultimately, foundry IC is fabricated where foundry. Your foundry cannot understand this behavioral form. Then what I should do? I should convert this behavioral form. I should convert this behavioral form to structural form. Structural form means gate and its connections. Whatever behavioral form you written, right, code, you have to convert into structural form. That phase is called as a synthesis. Next comes the phase called as synthesis. Functional verification, right? Still it is continuing. Next, we went with synthesis. What is synthesis? RTL code, whatever you have, right? That you have to convert into what? Gate and its connections. That is synthesis. So converting RTL into gate and its connections. That is called as synthesis. So after synthesis, how the design is? Right? The design is like after synthesis, right? The design is like you have gates and you have these connections. Okay, and its connections like this. Like this. This is nothing but what? Is nothing but called as what? Synthesis. So you have converted a behavioral description, right? Whatever behavioral description you have, RTL coding, right? Whatever the behavioral description you have converted into gate level. Synthesis is nothing but converting to gate level. Even this gate level, your foundry will not understand. Foundry cannot fabricate an IC by giving this synthesis, right? Synthesized netlist. Foundry cannot give this. Foundry cannot understand this. Even this information, your foundry cannot understand. Foundry cannot fabricate IC by giving this gates information. It cannot do anything. Then comes the role of physical design engineers. After synthesis, right? Then comes the role of what? Our role. Whatever demo we are attending for today, that is why we are present. Physical design. We are attending demo for this physical design only. This comes after synthesis. Why physical design? Because after synthesis, the design in what form? Gate level, gate and its connections. But this information, if I give to foundry, foundry cannot fabricate the IC. So then what information I have to give to foundry? I cannot give the gate, logic gate like this. I have to give the layout of these gates. Right? What I have to give? What information I have to give? I have to give the layout. So how many of you know what is layout? Layout of a cell. So layout, see when you take this inverter, right? When you take this inverter, right? When you take this inverter, so this inverter has NMOS and PMOS. This is N well, this is N well, this P substrate, this P substrate, this is N well. Here you have NMOS, here you have PMOS, here you have NMOS. This is N plus region, this is P plus region. On top of this you have silicon dioxide, on top of this you have what? Gate. Here also you have silicon dioxide, on top of this you have what? Gate. So whatever you see from the top, right, top view is called as what? If you capture the top view, so top view is called as layout. So we have to produce a layout of a design. Only layout of a design a foundry can understand. Right? A layout of a design, a foundry can understand. We can understand everything. Sorry, foundry can understand this gate level design. It can understand this. So foundry can understand only the layout of a design. Foundry can understand only layout of a design. So what is role of physical design engineers then? What is physical design? So converting uh, logical gate level description, right? Converting a logical gate level description into physical information, physical or layout, right? Layout information. This is called as what? Physical design. Only this information a foundry can understand. So ultimately, we are the last step, right? Physical design is the last step before sending the file to what? Foundry. Before sending the information to the foundry, we are the last step. So for that reason, it is called as what? Backend. Backend means we are the last step. So after synthesis, the design is present in after synthesis, right? The design is present in a gate and its connections like this. So what we have to do is this gates and connection information what we receive from synthesis, we have to convert into layout form. Right? We have to convert into physical information. That is a role of physical design. So while doing physical design, we have many steps like import design. We have many steps like import design, floor plan, placement, clock tree synthesis, clock tree synthesis, routing, right? And at last, right, sign off checks. Here PD completes, right? At last we have sign off checks. These are the steps in physical design. What is import design? See, I told you, right, that design engineers will use EDA tool to do any design. What are EDA tools? Electronic design automation tools. This will help to do any design, right, by using software. So we use automation software tool to do what? Designing of electronic circuits. That is called as EDA tool. So what EDA tool we are using then? Right? We are using a EDA tool of Synopsys. We are using a EDA tool of Synopsys. Highlight EDA tools here. What EDA tools we are using? So we use EDA tool from Synopsys. So we use for physical design, right? For physical design, we use ICC2, Integrated Circuit Compiler 2. 2 is a version. Earlier we had ICC1. Now we have what? ICC2. So we are using the ICC2, Integrated Circuit Compiler 2. So why I discuss this is I have import design, right? What is the meaning of import design? Import design means load all required files. Load all required files, required input files to tool, right? To tool, load all the required input files. So one of the file is your netlist also, correct? Synthesize information. So whatever we get from synthesis, right, that is called as synthesized netlist. So this synthesis information also we will load to the tool. Load all required input files to the tool. After that, right, floor plan. You have to go with floor plan. In floor plan, what we do is we will create like this die area. In floor plan, we'll create die area. We'll create core area. We will estimate this is nothing but IC. This die area and core area is nothing but what size of a IC. We estimate how many cells are there, right? In floor plan, what we do, we estimate how many cells are there. So cell information is present in synthesized netlist. The synthesized netlist, what I got. This gate information is present in a file called as what? Synthesized netlist. I have gates information. So I will estimate how many gates are there and how much area it is going to take. So based on that, I will plan my this core area. This is called as core area, and this is called as what? Die area. Now foundry wants this information only. Foundry wants how much should be my core area, how much should be my die area. Die area is nothing but the end of your chip, right? In between core area and die area, what you are going to place? You are going to place your IO pads. In between core area and die area, right? You are going to place IO pads. What are IO pads? IO pads are cells which is going to allow you to communicate from your core area to the outside world. Outside world signals, right? Signals we will get from outside world. So this will facilitate us to communicate from outside world to the inside of a chip. We have IO pads here. IO pads, what they will do, they will take the signal from outside world and they'll give to what? Into the core area. And any information from core area, they will send to what? They will send to outside world. Any information from core area, they'll send to what? Outside world. The meaning is IO pads are going to connect to your packaging pins, I can tell indirectly. IC packaging pins is IO pads are going to connect. Now you have to place your IO pads. So doing this is called as what? Floor plan. Creating core area, die area, creating core area, die area. See, we have a lot of things in floor plan that you'll understand when we go into the depth. Not only one step, you have a lot of things. You have IO pad placement, you have macro placement, you have having power planning. So you have plenty of things. So creating so floor plan, one of the step includes is also power planning. Right? The main thing in the floor plan is power planning. Means how to supply, like you have from the power station, you have to supply power to all the homes, right? Then the power grid has to be estimated. Power grid has to be created. Power grid, they'll do the estimation. How to supply all the powers to entire home present in Karnataka. There is a central power grid. From central power grid, the power will be the current or the voltage will be passed to the other power grids. From power grids, it will be passed to transformers. From transformers, it will go to the electric poles. From electric poles, will come to the home. Similarly, we have power structure in IC also. We have IO pads. We have power pads. From power pads, power will come to the straps. From straps, it will come to the stripes. From stripes, it will come to the from IO pads, it will come to the straps. From straps, it will come to the rails. From rails, it will come to the cells. Cells means gates. So we have power planning structure. So we have to do power planning here in the floor planning stage. So this is called as a floor planning. So why we have to do this floor planning? Why the electric department, that is a electric department, why they are doing the power planning like this? Because they have to supply proper power to each and every home without any losses. They have to reduce the loss, right? They have to reduce without any with the loss of less loss of power. They have to distribute power to all the houses. Similarly, we also with less loss of power, right? We have to supply all VDD and VSS to all the cells. See, there is always a IR drop. There is always a IR drop. What is called as IR drop? You have a port here, VDD. This is a 2.5 volts. VDD is how much? 2.5 volts. And I have one gate. I have one gate. It is connected through a metal layer, a length of a metal layer. If I have more length, right, length of a metal layer is more, it is having some internal resistance. If length of a metal layer increases, resistance also increases. So this metal now is having some internal resistance. So now this cell is drawing some current, few amperes of current is drawing. So according to the Ohm's law, some voltage drop will happen across my metal layer also, because it's having resistance and current is flowing. So out of 2.5 volts, some 0.4 volts will drop here. So what amount of voltage will reach to your cell? Out of 2.5 volts, 0.4 volts is dropped across your metal layer. So how much remaining voltage will come to your cell? Only 2.1 volt. There is a loss of voltage, right? Why there is a loss of voltage? Because of long metal layer. Long metal layer, more resistance. If metal layer is short, correct? If the metal layer is short, less resistance. Any of this cell is going to draw the same current. How much it was drawing here, this cell is going to draw the same current. But IR drop here is less because of net less length. So there is less IR drop. Here there's IR drop. So when there is more metal layer length, you have more IR drop. So what is IR drop? So even though your VDD is 2.5, but how much it is reaching to the cell? 2.1. Where this 0.4 went? That is a voltage drop on metal layer. So all these things, right, we have to take care while doing this floor planning. We have to reduce this IR drop in such a way that we have to do the power planning. So next is placement, right? Placement. Better what I do? This information, core area, die area, I write this side. This is a die area. This core area. What is placement? So I have cells. Cells means gates, right? So placing all millions of gates. Gates are not in small count. We have in lakhs or 10 lakhs. Placing all these gates inside the core area. Placing all the gates inside the core area without overlapping is called as what? Placement. What gates I am placing? Layout of a gates. What I have to place here? Layout of a gates. What is layout? You should understand that. That is what is layout. If you don't know, then you have to go refresh your CMOS basics. This is every UG should have this syllabus. What is layout of a cell? So layout we are not drawing. we are not drawing the layout of a cell. Remember, layout of a cell is drawn from layout team. There is a separate team called as layout team. They will draw the layout of a cell and they will give us in a file called as LDF file. That file we have already loaded. I told here, right? Load all the required input files to the tool. Layout exchange format. There is a file called as layout exchange format. They will give us the layout of all the cells in this file and we will load this file to the tool. So layout of a, we are not going to create the layout. We are placing the layout of a cell, right? So placement is not so simple. Placement is very complicated. It's not like simply bring the cells and place inside the core area. I have to place in such a way that I have to meet the timing, I have to meet the power, I have to meet the area requirement. See, if your father tells, right? If your father tells, go to VLSI Guru and come back, whatever method you want, you do. Then it's easy, correct? But the same father tells, do along with only go to VLSI Guru only with 20 rupees, then it's difficult. You have to catch the bus, you have to wait, right? And you have to come to institute and you have to complete all your work within what? 20 rupees. So what is 20 rupees? It's a constraint. Similarly, placing cells, right? If there is no constraint, it is very easy. But place the cells by meet the timing, meet the frequency of operation. Place the cells, right, to meet the power requirement. Place the cells with less congestion. Then it is difficult. So if we have any constraint, then it's very difficult to do the job. So placement means what we do in placement, place all standard cells, place all standard cells in core area without overlapping. That is called as what? Placement. So what we are placing standard cells means a layout of a standard cell, because I already told in the beginning, Foundry can understand only layout of a design. It cannot understand logical information. It cannot understand this symbol. Foundry can understand this symbol. What is the symbol? You can understand it. So we have to write the layout of this gate and we have to place. So we are not writing the layout. I told it very clear. We take the layout of a cell in a file called as LDF file, and that information we are going to place here. So this box indicates we have layout of a cell. So here we may having layout of OR gate. Here we may be having layout of an inverter. Here we may be having layout of a D flip-flop. All the layouts we are placing. Next is a clock tree synthesis. Next step in physical design is a clock tree synthesis. So in a design, right? In a design, if I take, I have one clock port. I have one clock port. This clock port, from this clock port or clock IO pad, right? I will be getting clock. And this clock port, it should connect to all the registers, right? All the flip-flops. Because all the flip-flops require clock. How many flip-flops are present in a design? You have lakhs together or thousands, 10,000s. So one clock port is connecting to 10,000 flip-flops. Because all the flip-flops want clock, right? This one clock port is connecting to what? 10,000 flip-flops. So load on this clock port is very high. So because of that, you will get many problems like max transition violation, max capacitance violation, cell delay will increase because one port is connecting to all the flip-flops, all the clock pin of a flip-flop in a design like this. So this will lead to many problems. So what we do is we will build a clock tree. So you have a clock port. Okay. From clock port you drive, right? From the clock port you drive only 5 buffers. From the clock port, you drive what? Only 5 buffers. Like this. Buffers means what? What is the input? The same output you are going to get. So what is the load on this clock port? Only 5 cells, correct? Earlier, what was the load? Thousands or 10,000 gates, flip-flops. Now we have only 5 cells. Each cell, each buffer, you drive another 5 buffers. Each buffer, you drive another 5 buffers. Like that, you drive another 5 buffers from each buffer. So each buffer, right, you give what? 100 flip-flops. Each buffer, you drive what? 100 flip-flops. Now, what is the load on this buffer? What is the load on this buffer? 5. What is the load on this clock port? Only 5 buffers. So thereby we are reducing the load on each cells. So this method is called as what? Clock tree synthesis. So in CTS stage, what we do is what is the problem if you don't do CTS? What problem we face? How to solve this problem? After CTS, how the problem reduces? So all those things we are going to discuss in CTS and how to do clock tree synthesis. How to do efficiently this clock tree synthesis. What are the parameters governing clock tree synthesis? You have skew, you have latency, right? All these things you are going to learn. What are the parameters it is going to govern, right? So what is clock tree synthesis? Nothing but building a clock tree, building a clock tree by using inverters and buffers. Right? This is called as a clock tree synthesis. Why we are doing this? To reduce the load on the clock port. For this purpose, we are doing clock tree synthesis. So now after clock tree synthesis, extra cells added to the design. What are the extra cells? Those are buffers. Buffers are added to the design. We don't have same count, right? We have extra count, extra cell count we have. So now I have placed the cells, but connection between the cells I have to do, right? These connections are required. Only placing layout of cells is not sufficient. I have to form what? Connection between the cells. So what is routing? Routing is nothing but connecting the cells through metal layers. I have to connect the cells like this through metal layers. Connecting the cells by using what? Metal layers. Connecting the cells by using metal layers is called as what? Routing. So I should connect without what? Without shorts. Unnecessary metal layer should not short. So that is called as routing. Connect cells using metal layers. So not one cell, 2 cell, 10 cells, 100 cells. You are responsible for connecting thousands of cells. You should connect without shorts. This is called as what? Routing. After performing this routing, right, you can do some sign off checks like power check, how much power it is consuming, right? Power or IR drop check. I told you IR drop, right? What is IR drop? I gave an example here. That clock, if the power port is having 2.5 volts to the cell, how much it will reach? 2.1 volt because of what? Long metal layer. So power or IR drop check you do. Next, right, you can go with timing check. Timing check means whether your design is working with required frequency of operation or not, frequency of clock. If your clock is 50 megahertz, whether your chip is working for 50 megahertz or not. Right? You have to do timing check. In timing check, you are going to do setup and hold analysis. That you will learn. You are going to do setup and hold analysis. Right? At last, you are going to do DRC and LVS. That is called as physical verification. You are going to do DRC and LVS check. DRC stands for design rule check. What is meaning of DRC? Design rule check. So your foundry has some rules. See, I am connecting one metal layer to another metal, one cell to another cell, right? By using metal layer. Between metal layer, I should be having some spacing. One metal layer to another metal layer. I should not be having two metal layers very close. If I have two metal layers very close, my foundry cannot fabricate. So foundry has plenty of rules like this. So whether my design is meeting all these rules or not. So that rules foundry has given in a file called as a technology file or in a foundry unset file. That file I have already loaded to the tool in the import design stage. So during DRC and LVS check, I'm going to check whether during DRC check, I'm going to check whether all the design rules are maintained or not. What foundry requires. LVS means after synthesis, right? What is a netlist? I have got synthesized netlist information. So this NOT gate is connecting to AND gate. This AND gate is connecting to what? D flip-flop. Whether the same connection is maintained here or not by using metal layers. So synthesized output is called as layout. Sorry, synthesis output is called as schematic. I'm very sorry. Synthesis output is called as schematic. And what is this? Layout. So in the schematic, whatever the connections I have, the same connections are maintained in the layout or not. That is called as LVS. Layout versus schematic. However, you got synthesized netlist, right? What are the connections you have there? The same connections here you have or not. So that is called as what? Layout versus schematic. But you will not check with synthesized netlist, you will check with routing netlist. Routed netlist. So netlist is called as what? Schematic, and this is called as what? Layout. So both connections you are checking whether same connections are maintained or not. That is called as a layout versus schematic. So in your schematic, right, you have connection from D flip-flop to mux. But here this is your D flip-flop and this is your mux. Here you should be having connection according to your schematic. But here you don't have. Then your LVS check will result in open. There is one open net which is not connected. Right? There is one open net which is not connected. From D flip-flop, I should be having connection to the mux, but that connection I'm not seeing. There is a violation. There is no connection, right? In the schematic, there is no connection between cell A and B. In schematic or in the netlist, there is no connection between the cell A and B. But in the here, I have connected. By mistake, I have connected. That is called a short. There is a short detected. Right? So that check we are going to do in LVS. So after doing this, right? After doing all these checks and all the checks are validated, all the violations, there is no violations. Then we create a GDS file. Last step is we create a GDS. So in GDS2 file, what is GDS? GDS file will create a graphical data stream file, right? This has layout, right? This has layout of a cell, layout of our design. This has a layout of our design. This layout, right? Whatever the layout I have here, this information I write in what format? GDS format. So layout of our design. And this GDS file, we will forward to what? We will forward to Foundry. This we will forward to what? Foundry. And my Foundry will fabricate IC according to this information. GDS2 information. What are the information given? Then what is the role of PD engineer? Converting your gate level information, what you got from the synthesis team, that you convert to what? You convert to physical or layout information. That is role of what? Physical design engineers. So all these things we use by using what tool? EDA tool, and EDA tool name is ICC2. So for doing this, right, all the steps, import design, floor plan, placement, CTS and routing, to do all these things. So we have a physical design tool called as ICC2. So before PD, right, we do synthesis. Before PD, we perform synthesis. For performing synthesis, we have DC shell or design compiler. For ICC2, sorry, for physical design, we have ICC2. For timing check, we have prime time. I told you sign off check, right? This sign off check, timing check. What is the tool what we are using, separate tool. The check can be done even in ICC2, but prime time is very accurate. Here we have ICC2, right? Even I can do the timing check in ICC2 also, but prime time is very accurate. So we have timing check, we have prime time. For RC extraction, we have star RC. After routing, I have to extract parasitic information. Parasitic means this metal layer is having small amount of resistance and small amount of capacitance. So we are not connecting this. This is not required for our design, capacitance and resistance. But they are forming because of virtue of their nature. That is called as what? Parasitic capacitance resistances. So we extract this. See, because of this parasitic capacitance resistances, right, the delay of a design will increase. Even this, that is called as net delay. The signal outputting here from here at 1 nanosecond, that will reach to other cell after 1.3 nanosecond. What is the delay of a net? 0.3 nanosecond. Net also has some delay. To estimate what is the delay of a net, we want resistance and capacitance information of this net. We want resistance and capacitance information. To extract this resistance and capacitance, we have a tool called as star RC extraction, right? Star RC. And for physical verification, we have IC validator. We have IC validator. ICV, I write it as ICV, IC validator. So this DRC and LVS check, at last I will write sign off check. To perform this DRC and LVS, we have IC validator, ICV. So these are the tools of what you are going to work on. Right. So I told I'm going to discuss about three agendas. Why, what is physical design? In brief, I have told why and what is physical design, what we do in physical design. So next, I'm going to talk about syllabus and timing of the course. So before that, if you have any doubts in why and what is physical design and what are the tools used, right? You can discuss with me before going to the next step. If you have any doubts, you can discuss.
Hello, sir.
Yes, please tell me.
What is the role of people in physical design?
Yes, please repeat once
Okay,
again.
yeah.
What is the
Hello,
role of
sir. Can you hear
people
me?
in physical design?
See, 2 to 3 persons are talking at a time, one by
Hello.
one. So go on. What is the role of a tickle, right? A TCL, you're telling.
Yes, sir. Yes, sir.
Yes. Um, I will discuss about this.
Sir, can you hear me now? Hello.
Yes, yes, it's audible. Tell me.
Yeah, actually, you told in physical design we are going to use it that ICC tool, right?
Yes.
So, like the
Yes, tell
industry-wise,
me.
yeah. So the industry-wise, like there are various EDA tools, right? Uh, so mostly whether this ICC tool is used in the big companies like Samsung or like Intel, like that, or like if we going to attend an interview,
See,
so
okay.
yeah.
Yes. See, EDA tools, only two EDA vendors are available for this. One is Cadence, another one is, right, when I talked about this EDA tool, right? One is Cadence, major EDA vendors are from Cadence, another one is what? Synopsys. So we are using all the tools from Synopsys. So one more EDA vendor is Cadence. Cadence
Okay,
has equivalent tools for this, right? So few companies will use Cadence tools and few companies will use Synopsys tools, right?
okay,
So it
sir.
depends upon. See, I have seen many companies using Synopsys tools. So few companies, according to their convenient and their MOU with Cadence or Synopsys, they may use another tool also like. So two major EDA vendors are Synopsys and Cadence. Mental graphics, right? We use few tools like Caliber. For example, I told for ICV, right? For here, physical verification, I used ICV. Instead of ICV, most of the companies will use Caliber tool.
Okay, okay,
Caliber is from Mentor Graphics. So from Mentor Graphics, they use Caliber. That is very famous. See, we cannot use other vendor tool because tool is very costly. Right? Tool is in lakhs for 1 year. So we have to pay 30 to 40 lakhs for 1 year. It's not so easy to get the tools, these EDA tools. Right? But according to their requirement, companies will use whether either Cadence tool or they'll use Synopsys tool. So only from Mentor Graphics, we use only Caliber for this one, physical verification.
okay, okay,
So
sir.
the
Okay,
equivalent tools, right? What are the equivalent tools for synthesis from Cadence side? I'll write Cadence side here. We use DC shell from Synopsys. There is an equivalent tool for Cadence also. So Cadence tool has genus. Cadence has genus for synthesis. Both will perform same role, same steps. Only small commands will change. So physical design, we use ICC2. If Cadence, any company is using Cadence means they will use Innovus. So here we use prime time, they use Tempest. For timing closure, right? For timing check, they use Tempus.
Okay.
For RC extraction, we use star RC, they will use QRC.
Extraction.
For physical verification, they will use PVSR, right? Physical verification system.
So the almost all the it will be similar, right? So if you learn this one, maybe if you want to adopt that one, it will be
It will be
easier.
similar, only commands will change.
Okay. Okay.
Yes. See, what is important is flow is important. What are the steps you use? Whenever you take any tool, right? For example, I take a tool of DC shell. I don't know what is DC shell. You imagine I don't know what is DC shell. I have given that tool, but I know what are the steps to be done. Synthesis, what I have to do? First, I have to read the design. I have to perform, elaborate. I have to validate the first. I have to validate the RTL. Then I have to perform, elaborate. Then I have to perform. I have to read the HTC files. I have to read other files. Then I have to perform compile ultra. I have to compile the design. I have to do the optimization. I know the steps. So then DC shell, right, or genus, they will give me the user manual. When I purchase the tool, they'll give me the user manual. User manual means what step, how to do that. I know how to do compiling, I know how to do optimization. How to do that? That is present in user manual. So by using user manual, you can easily do that. So, but you should be knowing
Okay.
the flow. That's it.
Okay. Got it. Yeah, thanks.
Hello, sir.
Yes, tell me.
During the floor plan stage, like there's and there's IO. So if the IO bad area is like it has gates, or it is only like bumped.
So you're talking about IO parts, right?
Yes, sir.
This IO parts you're talking. See, IO parts are nothing but I already told you, right? These are like a cells, right? Or they are called as pads, which is we are getting the signal from outside world to the inside of a core area. So this is not a cell, it is having some protection circuit like ESD protection, electrostatic discharge protection. It's, if you want, you will be having some level shifters to convert the signals. So outside world signal level may be different, or inside core area signal level may be different. Right. So mainly thing what is present in IO part is nothing but ESD cells, right? Electrostatic discharge cells.
Okay, got it.
So this
Sir, one
protection
more thing.
circuit you have. Yes.
Sir, in the DRC, right, it is only used, it is only done like using tickle scripting, or it can be done manually also.
So tool will do that. Right? Check the tool will do. Fixing you can do by any method. You can do manually. You can do by TCL scripting. It's
So,
up to
sir,
the
physical
designer.
design engineers will do manually also.
See, your voice is
Like
breaking. Please go ahead once again. Hello.
so as a physical design engineer,
Please
we
tell
have
me
to
from
do
the
manually
beginning.
also.
See, it depends upon how much violations you have. If you have 5 to 6 violations, you can do manually. If you have hundreds of violations or 200s of violations, you can do by TCL scripting. So TCL scripting you can do if you are very experienced and if you handle the tool many times, then only you can do. So both methods can be used.
Sir, like I heard that if it is not possible with tickle and there are too many violations, sometimes they give it to layout team.
See, physical verification is separate team again. We cannot tell that it's a layout team. It's a physical verification team. Physical verification team, they will do it. See, manually is nothing but what remove this metal layer and reconnect it, right? So see that how to reconnect it. For example, there is a short here. One more metal layer is going here. Right? One more metal layer will be shorted here. So remove this metal layer. Reconnect it. Try different ways to reconnect. That is called as manual method. So we will teach you manual method, right? And even TCL method, how to do automated fixing of shorts and right? Shorts and opens or any DRC violations like same net spacing, differential net spacing. If you have any violations, how to do manually and how to do automated way by using TCL, both will teach. So you adopt whatever way is easy for you. It depends upon the situation, right? What is the situation? And see what happens whenever we use TCL, tool cannot do everything. Tool is not able to do everything. So tool will end up with the same violations again and again whenever you run. At the time, what we have to do is okay, if tool is not doing, I have to check what are the different methods we have. Then I should go with manual method only.
Understood, sir. Thank you.
Okay. Now the thing is right syllabus. The input files explanation we'll do during the course. So it takes if I want to explain all the input files, it takes more than 1.5 hours. Like .lib, library file, LEF, layout exchange format file, technology file, TLU plus file, right? Netlist, scanDef file, UPF file. If I want to explain all the 7 to 8 files, right, it will take more than 1.5 hours. We will do during when we go with the course, right? Obviously, we have to do that. Without understanding the input files for PD, we cannot do the design. Obviously, we are going to do that. If you want to name, I will name the files. You want me to name? Okay, but see, metal layer is small. So the VDD, whatever I have used, right? If the technology is scaled down, 2.5 volt, I used like 45 nanometers using 2.5 volt. But when we come to 7 nanometer or 14 nanometer, what is a VDD? VDD itself is 0.75. 0.75. And this cell, what is using this VDD, right? If there is small voltage drop, like the voltage drop is 0.1 volt, small voltage drop because of small net length, right? I am not telling very huge voltage drop. I'm telling very small voltage drop. If voltage drop is like just 0.1 volt, so how many volts I'll get here? Only I'll get 0.74 volt. So sorry, 0.64 volt. So you know what is threshold voltage? If VDD itself is 0.75 volts, what will be the threshold voltage? Threshold voltage of a cell will be like 0.1 or zero point 0.2 volts. If there is 0.1 volt drop, that will lead to a problem. If your VDD also reduces, if VDD reduces, your voltage drop should also be less. At that time, 0.1 volt drop will also create a problem. So earlier case, what I explained is your VDD is 2.5 volts. So when it reaches to the cell, right, it is 2.1 volt. So what is a drop here? Like 0.4 or 0.5 because of bigger VDD and long metal length. So when your technology scales down, you will be having very short length of metal layer. So every metal layer, if it is very short or very short, some sort of voltage drop will be there, 100%. If metal doesn't have any voltage drop, then it becomes ideal. Only gold or silver can do that. No metal, no voltage drop. That's so. What is our role is to reduce this voltage drop. We should see that we should not be having very bigger length of metal layer. So this voltage drop is increased. So we have to reduce the voltage drop. So I told I didn't tell that voltage drop will be there 100%. Our role is to reduce the voltage drop. We have to design in such a way that to reduce the voltage drop.
One more doubt actually. Hello.
Yes, tell me.
Yeah, you told voltage
Yes.
drop, right? Yeah, that is mainly due to
Yes,
the
tell me.
current actually. Yeah. Current and the resistance,
Yes.
right? So this
Yes, yes.
current and everything, yeah, who will give the details actually? This 3.3 volt should carry up to 10 amps, like 15 amps. So based on that only we will get to know how much resistance has to be, like how much distance or like path has to be
See,
reduced. Right?
see, your voice is very low. Can you be a little bit louder?
Yes, sir. Actually, this voltage drop is due to the uh, mainly due to the current. Actually, so if current is more, the
Yes.
resistance is higher, then obviously the voltage drop will occur. Right. So uh, this detail actually who will provide how much current has to be given, like how much this requirement who will do it. Hello?
Yes, 1 second. See, I have, hello.
Yeah. Can you hear me, sir?
Yes, I can hear you. Now you tell me.
Yeah, this whatever you told, like voltage drop and everything, that is mainly due to the current. So if the current like more current, then obviously path resistance is high, voltage drop, right? So this
See, you have a
requirement, like
lot of noise, which I'm not able to get properly.
okay,
Whether what is your
uh,
doubt, you can type in the chat box. You please type in the chat box.
1 minute, sir. Now you can hear me actually.
Yes, now it is clear. Tell me.
Yeah, actually my doubt is like this voltage drop, whatever you said, that is mainly due to the current actually. So if current is too high, like 20, 15 amps or something like that, so the path resistance is, will have a voltage drop. So this requirement, like how much current and how much this property and all, we will give it actually. This path and like this has to be maintained this much, this detail and all.
Surya, your voice is not clear.
Okay, sir. We'll like later actually.
Your voice is
May I
not
come?
clear. I think you can type in the chat box. You can take time and you
Yes.
can type in the chat box. I'll respond to that.
Okay, sir. Yeah. Okay. Later. Yeah, we can
Yes.
continue.
Okay. I'll go with syllabus. You can type in the chat box meanwhile. Right? What is your doubt? See, I told right we are using EDA tool and we are doing physical design. To do physical design, what is important? See, you should be knowing the digital basics. If you are good at digital basics, you can understand everything, not only physical design. Whatever the gates we tell, even front end, you can understand only if you are good at physical digital basics. Like you should be knowing what is mux. If I tell mux, you should be knowing what is meaning of mux. If I tell asynchronous reset, what is meaning of asynchronous reset? Can anyone tell me? The operation of reset doesn't depend upon the clock. Right? I have flip flop here, yeah, right?
Sir, I'm
And I have a reset
2012
signal
pass out.
here.
Hello.
Yes, please tell me. Yes, tell me.
Sir, I'm 2012 pass out. I forgot everything.
I'm
I
just
forgot
please
everything.
please listen. Right? You can discuss in the last. Right? I'm discussing
Oh,
same thing. What we cover also we'll discuss.
oh.
Okay. So if I tell asynchronous reset, you should be knowing what is asynchronous reset. If I tell synchronous reset, you should be knowing what is synchronous reset. D flip flop, if I tell, you should be knowing what is D flip flop or counter. What is the meaning of counter? So first thing is you should be knowing digital basics. Means what circuit, what is the meaning of a circuit. After knowing a digital basics, right, you should be knowing CMOS basics. CMOS basics. What is meaning of CMOS basics? You should be knowing what is MOSFET, what is NMOS, what is PMOS, what is CMOS, what is power dissipation in PMOS or in CMOS, what is layout, what is fabrication steps in foundry, what are fabrication steps they follow, and what is the layout. If I have AND gate, what is the layout of AND gate? If I have NOR gate, what is the layout of a NOR So you should be knowing layout. So all those things is coming under the category of what? CMOS basics. So few UG courses has a syllabus, few UG courses doesn't have the syllabus. CMOS basics. If you know CMOS basics, you can ignore this basic part. After this, right? See why we want the CMOS basics. CMOS basics I want because we are placing here layout of a cell, right? What we are placing here? Layout of a cell, layout of OR gate. First I have to draw CMOS structure of OR gate. After drawing CMOS structure of OR gate, then I have to write the layout of OR gate. Anyhow, we are not drawing the layout. Layout team will draw the layout. But we should be knowing what is present in that. So to handle the violations, if I have any violations, what is present in that. So understanding CMOS is very, very important. CMOS basics. After CMOS basics, right, you should be knowing Unix commands. What is Unix? All EDA tools, Cadence or Synopsys, it is installed in Unix operating system or Linux operating system. We install all these tools are installed in Linux operating system. We use Linux because it's virus free, right? And Linux is used because so we can easily handle the operating system by using Unix commands. I can create, see, if I want to create a 10 directories, 10 folders I have to create in Windows. What I should do? Right click new folder, give one name. Right click new folder, give one name. Right click new folder, give one name. 10 times. But in Unix, right, I can directly use Unix command, means make mkdir, make directory, and give 10 directory names like directory name is a D1, D2, D3, D4, D5, D6, D7. So what this command will do, it is going to create 10 directories with these names. What are the names you are giving? Simple thing, right? But the same thing if I want to do in Windows, right? What you should do, you should right click new folder, give the name, right click new folder. 10 times you have to do this. So Unix commands will make you to easily handle your operating system to do your operations. Why you have to create 10 folders? To do my PD, right? One folder is required to store all my input files. One folder is required to store all my log files. Whatever I'm doing, log files, whatever I'm getting, I should store all the log files. One folder I want to store all my script files. One folder I want to store my library files, lib files. One folder I want to store my output file reports. So like that I want different folders. So if I want to create the same thing, right, if by using Windows, that it will take more time that I can do using Unix easily. So you have plenty of commands like this in Unix. How to create directory, how to copy directory, how to copy files. Same operations what you do in Windows, right? Right click, copy, right click, move, drag and move. Everything you will do by using commands, that is called as Unix commands. Industry expects you should be knowing Unix. So what are the operations? Windows, creating a folder. There is a command for that. Copying a folder from one location to another location. You are done through GUI. You have a command for that. Moving a folder, you have a command for that. Copying a file, you have a command for that. Along with that, you have some different commands also, like grep command, awk command, to find some files. What is the content of a file or content of folder? You have D1 folder. What are the things present? I'll use one terminal. Just I'll go to D1 folder, CD. CD means move to what? D1 folder plus LS. LS means show me the content. What are all the files present in D1 folder? So like that, you will study many that is called as Unix commands. You will study in the basics. All right. So this Unix commands is very important. After that, you should be knowing a TCL command. TCL, right? You should be knowing TCL, tool command language. What is tool command language? What is TCL? TCL stands for what? Tool command language. See, EDA tools, this tool command language is inbuilt. TCL in ICC2. TCL is inbuilt in DC shell. TCL is inbuilt in ICV. TCL is inbuilt in prime time. So TCL is inbuilt in Innovus. Innovus is a cadence tool. In that you already have TCL. Tool command language is inbuilt. TCL is inbuilt in right genus. Like all the EDA tools can understand only what? TCL. Here one cell. I have one cell. This cell I have. For this cell, right, I have to apply one keyboard margin, right? Because near to the cell, I don't want to place any other cells. I want to apply one keyboard margin like this. So do this operation for all the cells. How many cells you have in the design? How many cells you have in the design?
Millions of cells.
This keyboard margin I have to apply for all lakhs of cells. If you do one by one, you will get frustrated. You will not do that. One by one, if you start doing, right? 10 lakh cells you cannot do. What you can do? You can use TCL. You can call each and every cell by using one loop, for each loop. For each loop, by using for each loop, you can call each and every cell and you can apply that keyboard margin. For each and every cell, you can do that. So in this location, I have 200 IO pads, right? I have 200 IO pads. I have to place all these 200 IO pads in this location. Only in this location I have to place, right? Like this, right? One IO pad, right? One IO pad. After one IO pad, leave 2 micrometer distance, another IO pad. 2 micrometer distance, another IO pad. 2 micrometer distance, another IO pad. So like this, you have to place 200 IO pads, one after the other. Whether you will drag and place it, you can do. You can drag and place it, no issues. Then you should exactly measure 200 micrometer here. You have to place one more IO pad. 200 micrometer, you will place one more IO pad. So instead of doing this manually, you can write TCL program. You can tell the tool, right, by writing TCL program, tool will place it by reading the TCL script. You can write that. So TCL will make, right, TCL will make your design very easy if you know tool command language. So your EDA tools can understand only TCL must. You should be knowing that. Apart from TCL, right, few companies will ask for Python and few companies will ask for Perl. Why, for what purpose? So I have timing, right? I have timing scripts here, right? I'm doing timing check here. While doing timing check, I have timing reports. There are 500 paths violating. I have 500 path timing report. So out of 500 paths, first I want to fix few paths. So I have 500 paths violating. I have dumped all the 500 paths in a file. There is a file. This file is having 500 paths. So in this 500 paths, I want to fix few paths, all right, based on some criteria. I want to fix only few paths based on some criteria. This information I have to extract from this file. I have to do some file operation. Compare one word and extract. So compare the start point which is belonging to. So first I want to fix the path which is belonging to iris core family. There is a family called as iris core family that design. I want to fix only timing from this. Out of 500, I want to extract only timing report of iris core family. Then what I can do? I should do some file operations. For doing this file operations, I can use TCL, I can use Python, or I can use what? Perl. So TCL will also help you doing tool command operations as well as file operations. You can do file operations. So in this TCL, right, you are learning basics of TCL, how to do file operations, what are the loops in TCL, right? What are the loops in TCL? So what is regular expression? All these things. So all basics of TCLs you learn here. Means syntax along with the basic program. along with example programs. Basics you'll learn here. How to do mathematical operations by using TCL. What is the syntax? After that, 2 to 3 example programs. What are different loops in TCL? You have for loop, while loop, for each loop. What is syntax? How to write different programs by using these loops? 2 to 3 examples. How to read a data from a file? Syntax. How to write data to the file? Syntax. And 1 or 2 file operations. So everything you learn here. Apart from this, from few PD basics, few PD basic topics. In PD basics means what do you mean by cell delay? What do you mean by transition? So what do you mean by capacitance? PD basics. What are steps in physical design? What is the steps we have? I told you now. Little bit in depth, not very depth, small, in little bit in depth. All right. We will see in PD basics. So this all accounts for the basics. This all accounts for basics. I think I answered the question, right? Why TCL? I've answered. The one student asked me why we use TCL. So these are all the basics part of the syllabus. So advanced part. Next is advanced part. In advanced part, we do 2 projects with 28 and 14 nm technology node. In an advanced project, in advance, right? We do 2 projects with 28 nanometer or 14 nanometer technology node. Means a transistor channel length is 14 nanometer or 28 nanometer. So how this works is, right? We have divided this into 2 parts: theory and lab. I'm only telling for advanced. Distal, it is like every day. Sorry, basics. Sorry. Basics is every day. Every day, 3 hours basics will be done. From Monday to Thursday. Friday is a week off, and again Saturday and Sunday it will be done. So that syllabus admin will post you. So sorry, timings admin will post you. Every day 3 hours of basics. So this basics will take 2.5 to 3 months. Total duration is 6.5 months. Total duration is 6.5 months. Complete with the basics and advanced. Both the 6.5 we take for basics. Next is the theory, right? We will go with advanced part. First is theory, because theory also you should understand, right? Each and every step. See, I have told everything in brief. So what we do, everything, right? Theory will be done only on the weekends, like Saturday and Sunday, 3 hours. Because we have industrial experts available only on Saturday and Sunday. Industrial experts, they will be available only on Saturday and Sunday. So we will do theory on Saturday and Sunday for 3 hours. So theory means not only theory, they will do lab also, but they will do lab a little bit fast. You cannot follow them. Follow them means you cannot do along with them. Following means you're not understanding. You cannot do along with them. So you can understand the concepts. Right? That is called theory. We are going to do Saturday and Sunday. This is for Saturday 3 hours, Sunday 3 hours, right? 6 hours per week. So I can write individually, then you should not get confused. This is 3 hours, this is 3 hours. Lab, right? When I come to lab part, lab means you will work on the tool. So tool will be given to all the students. When basics is completed, tool will be given to all the students. VPN will be given, you can work from home also. So lab will be done. Lab is divided into weekdays weekdays for the students who are available on weekdays. Right? Weekdays lab is for students who are available on weekdays. Available on weekdays means few persons will be working. They are not available on weekdays. They can work only on the weekend. Again, lab is divided on weekend. It is divided to the
Hello.
weekend.
Yeah. Hello.
So weekdays. So weekdays lab is from Monday to Thursday. So Friday is a week off, and Saturday and Sunday you have theory sessions. So Monday to Thursday is 3 hours. Weekend after the theory session, right? After the theory session, Saturday and Sunday you have theory session. After theory session, you have lab. It's Saturday and Sunday. It's only for weekend students. Don't attend both. You'll get confused because that trainer will be different, this trainer will be different. This is for 3 hours. This is for weekend students. After the theory session, Saturday and
Hello?
Sunday, theory session is common for both. For weekday students and weekend students, there is common for both. After theory session, weekend student is going to attend lab, right, for the next 3 hours, Saturday and Sunday. So weekday students, they have lab from Monday to Thursday for 3 hours. Right. So we are going to do two projects. So on 28 nm and 14 nm. Here we do all the steps of all the steps of physical design. So few programs using advanced TCL, right? I mentioned here. So advanced TCL. So Unix commands. How to use, already you have learned Unix commands. How to use Unix commands while working on projects. How to use TCL while working on projects. How to use GVim commands. GVim is a text editor. What is GVim? Text editor. In Windows, you have text editor, right? Notepad you have. Similarly, you have GVim. So there is GVim commands that will make me to use a file very easily. So how to use GVim commands, right, to make your design very easy or design process very easy. How to use the GVim commands. So all these things we are going to study in advance. Don't forget this. It's not only about TCL, along with all the steps of PD, from floor planning to the sign objects. We'll do this. So this is about your syllabus, right? So if students are good with basics, right, they can directly join to advanced course. If students are not good with basics, then they can take even basics. Then they can join for what? Advanced course. So the cost, right? What is the cost for basics and advanced? Admin is going to inform you. I'll call him after your queries.
Basics means
And
digital basics, CMOS basics, Unix commands, this thing we should know, sir.
all these things completely.
Which all? Digital basics, CMOS basics, Unix basics, TCL and PD basics, sir.
All these things come under basics. All these things, right? Projects, theory, lab about advanced PD, theory about advanced PD. All these things will come under advanced. All these things, digital basics, CMOS basics, Unix basics, TCL basics will come under basics, PD basics.
So daily
So this
for
basics is
advanced,
for 2.5. Advanced is for right. This is for 2.5 to 3.5 3 months. Advanced is for like 3.5 to 4 months.
so total 6.5
Yes, tell
months.
me what is your doubt?
Total
6.5 months.
6.5
Yes.
months.
Yes, 6.5 months. 6.5 months.
Sir, what are the timing for basics?
It will be general timing. Generally, most of the time the timing will be from 9:30 to 12:30.
Morning 9:30 to 12:30, sir.
Yes,
Hello.
morning 9:30 to 12:30. Sometimes it may vary, not every day. Sometimes one or the other day admin will inform you. Because
Will it be
sometimes trainer has
continuously or
something,
will there
then
be break in that?
yes, I didn't understand what is that. It will be continuously, right? Syllabus, see, this
Will
is
there be break in
digital
that or?
basics is done. We will take a 1 day break for you people to prepare, and after that we'll be having test.
Okay.
CMOS
Test
basics
and
is
all will
done.
be
1 day
on.
for preparation, 1 day for test. Yes, please tell me what is your doubt.
Daily it's 9:30 to 12:30 means it will be 3 hours, no, sir. Will it be continuously or will there be break in that?
Yes, yes. There will be 10 to 15 minutes break. Not more than
Okay.
15 minutes. It is between 10 to 15 minutes. You'll be having
Basic
break
class
in between.
daily.
Yes, please repeat once again. Basics.
Basic classes will be daily or it will be Monday to Thursday.
See, it will be from Monday to Sunday. Any 1 day break. Right. I think that the break is while doing basics. Right. The break will be on Sunday. Basics. The break will be on Sunday. Probably. That admin will inform you. Probably now, according to my knowledge, right, break will be on Sunday for basics, and for advanced, the break will be surely on Friday because Saturday and Sunday to teach you. They are available only on Saturday and Sunday. For advanced courses, the break will be on weekdays. It will be mostly on Friday. For basics, the break will be on mostly on Sunday.
So that will get over in
You'll be
December, no,
having
sir.
what part? Please repeat again.
So
What
course
you
will
do?
complete in December, right?
Yes, yes. See, minimum we want this much time, 6.5 months we want. See, we cannot rush with the syllabus. Minimum 6.5 months. See, industry experts a lot from the students. We cannot just do the course for a few months and we cannot send. Industry experts are strong and they
Sir,
expect a strong
can you
project from
can
the
you
students.
can you take classes like morning 9:30 to 12:30 and evening like 5 to 7 like that, like daily 5 hours, so that we can wind up
No,
with
no,
the
it's not possible. We are doing only 3 hours. It is not
what, sir?
only about the trainer, right? It's not only about the trainer, right? The issue is also with respect to tool, right? Tool also be adjusted.
Okay.
So the tools have to be adjusted. So we have other allocation we have to do. So it's only for 3 hours per day. You can be see you if you are in the institute, you can come for institute and you can work for 7 hours also. You can come at 9:30, you can work till 6:30. Right? No one is going
Sir, do
to
the
question you.
institute
You can
got
work
company
here, you can
also?
sit, you can prepare.
So do the institute got
Institute?
company also? Institute got company also?
Institute has got company also. That is what your question.
Yeah, yeah.
Yes, see, our
Lab.
institute is recognized with the company called SOCDV.
What, sir?
SOCDV, System on Chip Design Verification, SOCDV.
Oh, that's the company name, sir.
Yes, sir. It is registered
Uh,
with the company.
No, I'm asking, is the institute is also running a company?
No, no, it's not running a company.
Sir, I have a doubt regarding lab hours. It is Monday, 6
Hmm.
Tuesday, 3 hours. Is it like that? Every day, 3 hours?
Yes, Monday 3 hours, every day 3 hours it is. Monday to Thursday, every day 3 hours.
The 2 days will be for 3 hours
Saturday
daily.
3 hours, for weekends Saturday 3 hours, Sunday 3 hours. Yes, it is
So,
3 hours daily.
okay, access will be there for 2.
Tool access will be there for 24/7. But lab will be done only for 3 hours. You can practice after the lab also.
Sir, it will be good if you take 5 hours daily classes because we want to complete it early.
See, any specific thing, right? You can talk to the admin. Admin will make some arrangements for that.
Yeah, because I want to complete it in
Hours,
4 months.
tool access will be there.
No, what is it about? Tool access?
Tool access will be for 24 hours, you mean?
See, once advance starts, right, you can use a tool at any time you want. It's not only during the lab hours, you can use a tool anytime. If I do lab from 9:30 to 12:30, right, you will be following me whatever I do. And if you want to practice, you can practice anytime after 12:30. Right, anytime you can practice. Tool is for you for the next 4 months or 5 months. Right, after the completion of course also we will extend the usage of tool for next 15 days or 1 month. Right, so you can use at any time, not only during lab hours. You can use it anytime.
Instructor will be different for weekend lab hours and daily lab hours.
What more?
Instructor will be same or instructor will be different.
See, the instructor may differ from theory to the lab. He may differ because theory is done by industrial experts who is having experience like 10 hours, 10 years or
No,
more
no,
than that.
I'm talking lab hours daily and lab hours weekend. Instructor will be daily. The labs,
They may differ.
they may differ. Okay.
Sir, when
They
we
may
start
change. See, lab means what? Whatever the theory we are doing, right? The same thing they will do in slower pace. Like they will ask students have any doubt whether you're done or not, whether this command is executed or not. If you are done, next you will move to the next command, next process. Yes, sir, tell me.
sir, I'm a 2012 pass out.
Hmm.
I'm an ex-center government employee as well as I work as a video frequency engineer. But I took some gap due to some vision issues. So, will I get placed?
Yes, sir. See, I want to talk about placement. See, you have two types of companies called as service-based companies and product-based companies. Service-based
Yeah,
companies will recruit you and they will work on the projects of product-based companies. There is a X company, they don't have any their own products. They will recruit you and they will post you to work on what product-based companies. Product-based companies like Qualcomm or Intel or AMD or ARM.
yeah,
They work for their projects. So
okay,
service-based companies may take the the earlier pass of students and they can claim some experience. But if you are very good, right, if you are very good in your topics, right, you can join, you can get the job opportunities. See, you cannot be directly joining to the product-based companies. It's not possible because the reason is product-based companies will do background verification. You cannot claim any experience also. But service-based companies can accept you if you're very good, right? If your knowledge is very good, they can accept you.
What about the placement, sir? I want Hyderabad location.
Yes, you want?
I want Hyderabad location placement.
That depends upon the companies. At what time they are at that time when you are done with your course, right? So when you are arriving at that time, what companies are approaching us depends upon that. So even many companies approach with Hyderabad location also. Most of the
Can
companies
we
will
get
approach with Bangalore location. Few companies in Hyderabad also they will approach to us. So it depends upon at that time what companies are approaching.
for lab hours? Can we get a demo for lab also similarly? Because we are comfortable with the instructor, his delivery or not. We can we get a demo for that?
You can get a video from the admin, right? You can talk to the admin. Right? Our office team, they will call
Okay.
you,
Okay.
right? You can request for the video, demo video.
Okay. Okay.
Right? They will send you the demo video.
But But since you said instructor will be different for weekdays, so which instructor video they will be sharing, we need to ask them.
See, instructor will not be different so much. Like there will be not the way they deliver that may be differing. Content will be the same. For example, if I am doing the basic session, I used what some easy note. If some other person does right, he used some notepad to type the things. So how they deliver that is going to change, but the content remains same. So you whatever your query is right regarding the lab. So I have who will be my trainer? So you give video of him, right? You just ask the admin, he will give you.
Okay, sir.
So this batch is weekend or weekdays?
You are joining for which batch? Your weekdays or weekend?
I like to join weekdays.
Yes, then you can ask the admin weekdays video. Right? Just give me 2 minutes. Right? I'll call. See, I am from the technical background, right? I'll call.
Okay, okay.
I'll tell some person from the office, right, to the meeting. Just give me two
You
minutes. They will
you
ask.
will be
They will answer it.
the trainer for basics
Just
or
tell me.
advanced.
Yes, please repeat what you told.
Sir, you will be the instructor for basics or advanced or both.
See, I will not be taking basics. Right? I may take advanced part later. Basics is done by Chetan, right? Some other persons, Abhishek, right? Some persons will be doing basics. I will be taking advanced part later.
But you will be not taking lab, right?
Just give me 2 minutes. I will contact office
Sir, you
staff
will be not.
to.
Yes, sir, you will be not taking the.
Hello.
No, what is your doubt, my? I will be not taking the basics, right? That is what your question.
No, no. You will be not taking the lab, sir.
Hello.
Your question is I am not taking lab. That is what your question.
Yes,
Is
yes, sir.
Cosix sir is available for the basics?
So your doubt is whether see, I am not taking basics. You know what who I am, right? This is a basic session, introduction session, right? Whether you know who I am.
No, sir.
The Cosix sir is available for basics.
No, I didn't understand what is your concern, right? Concern, I didn't understand what is the concern here. Whether you people know who are the trainers of the institute, right?
So
See, I am not taking basics. I am Deepak, right? I am from the PD background. I am not taking the basics. Basics will be taken from the other instructors, right? Basics will be handled by Chetan or Kaushik or Abhishek,
yes, sir. Cosix,
right? Some
Cosix,
of the
Cosix.
trainers will take the basics. I will not take the basics.
Okay.
Probably basics will be started from the digital with the digital basics, right?
Yeah, are we done with the class?
Yes, any other queries you have?
No, are we done with the class?
Yes, sir. Any doubts you have, right, regarding lab, or if you want to get any lab video, right, you can contact to this number. Contact, or you can also do the message. You can also message to this number.
What's the number?
Just 1 second, I'll give you the number. This is the number of office staff, right, or our manager, right? He will guide you.
Hello,
Just tell me. Please tell me.
sir. How many members are present in batch? The course batch.
See, for the lab, right? Not more than 70. It is like we will be having admissions more than 30 minutes. We will be split into different batches. Morning one batch, afternoon one batch will do. If the students are less than
Okay.
30, we
Each.
will do only one batch. For example, sometimes
Okay. Okay.
the last two batches we handled, so there are like 75 students, 70 students. That we did two
Each
batches.
batch how
Morning
many?
one batch, batch. So not more than
I
30
am
students.
asking each. I am asking each batch how many members are contained.
It depends upon how many are joining, right? You sometime 70, 75 was the admission. So when I did, it was 75. PD join, it was 75. So some other batch it was like 50. Some other batch it will be like 45. Some other batch it will be like 65. So we are done the demo today. How many are registering for this batch? Depends upon that.
Okay. Thank you.
But at the time, lab will be done only for the 30 students, not more than that. If you have more
Okay, sir.
students, we
Thank
will
you.
split into two batches. So if you have any queries regarding fees, or if you want to get any videos, right, you can call to this number 99 861 941 91.
What's the good name?
99 861 941 91. You can contact to this number.
What is his name and what he does?
Right? See, our office staff or our owner, anyone they may pick this call. Our manager, right? These are number of our manager, Vaibhav. He's a VLSI Guru manager. He's a number of VLSI Guru manager. So Sunday he is not available today. So it is like if he is not available, any other person will respond to you. You can also do this, also the WhatsApp number, right? You can also message to this.
So from tomorrow, classes will start regularly, right?
Yes, from Monday the class will start regularly. So Monday we will not start with digital basics. Monday and Tuesday probably they may start with GVM basics. GVM editor we have, they will start with GVM basics because students are not sure. GVM it will be done again once again. When we do advanced, right, it will teach you the GVM commands. So, but we'll start with GVM commands so that the students may become they can join on Monday or Tuesday, and we'll get actual strength from Wednesday. So the session starts from Monday with the GVM. So Monday and Tuesday will be GVM, and again from Wednesday they'll start with the digital basics.
So what about the advanced level classes? When it will start?
It is after the basics. If see advanced, right,
Actually,
advanced
I'm
batch.
looking for
If you
advanced
don't
level.
want basics, right?
Yeah, I know basic. Right? I
Yes, sir.
already familiar
I'm
with
just answering
basic.
for that. I understand your query. Some students may tell that I am good at basics, I don't want basics, and I can go directly with advanced.
Yeah,
Then you need
exactly.
not to
I
wait
already
for 3 months. You need not to wait for 2 to 4. You can directly contact the admin or directly call to this number. They will
okay.
ask you to join for current advanced batch. Current advanced batch is starting now. They will ask you to join to current advanced batch.
Yeah. Actually, I'm looking for advanced level. I already familiar with the TCL scripting and the tool encounter also. That's why.
Yes, yes. I told you, right? You can directly join to the advanced batch.
Okay, thank you, sir.
Sir, can you please give a small introduction about yourself and the faculty who will be taking the lab?
So what is your name? The student who is asking the question.
Hello.
Hello. Yes, what
Yes,
is your
sir.
name?
Sir, Varsha Balani.
So, also I am Deepak. The demo is done by Deepak. Right? Right? The demo session today it is done by Deepak. So I have experience in training, right? Training the candidates for corporate and for college level also in VLSI. Right? I have experience from past 5 to 6 years. So I am heading the PD team here in VLSI Guru and lab trainers. Who will be the lab trainers? It depends upon, right, the trainers who are available, right, at that time. So we are running many batches, right? So which trainers are free at that time? Those trainers will be allocated to your batches. So probably I can tell only probable trainers. I cannot tell exact trainer names who will be available at that time. Even I cannot estimate. Right? It is after the basics, right? Now who is a trainer? Right? I can tell, but after the basics, if you're taking basics and if you're asking me after 3 months, right, I cannot tell who will be the trainer. So I can tell probable trainer. The trainers are Pallavi or he may be Rahul or Deepak. Right? Deepak means me. So these are probable trainers.
Yes, sir.
So I have told the admin, right? If you want demo video of lab, you can just contact this number and you can request for that. They will give the demo video of the lab. And any technical content, right? You can also contact me, right? It's not for like what is the fees. You don't please contact me because I cannot comment on any technical content. If you want information, please contact me. This is my number. Technical content. What projects we do? What is the quality of a project? That information you contact me. Technical content you contact me. Yes, tell me.
What about placements and what is the process of placement and which companies are visit at VLSI Guru Institute? Can you explain?
So you're asking about the company, right? Which companies has associated with VLSI Guru?
Yes, yes, sir.
Hello?
Yeah, it's
Yes, sir. Yes, sir.
See, you can ask in this WhatsApp group, right? They will send you the list of companies. You can ask in this WhatsApp number, right? They'll send you the list of companies who are associated with VLSI Guru. So here we have 40 to 50 companies we are associated. That includes even service-based, product-based companies. All the companies in the market, VLSI companies, they are associated with VLSI Guru because even if the companies want a student, right? If company want a student, obviously from VLSI domain, they will not approach to the college. They'll approach only to NITs or IITs. No UG courses will give students directly to the VLSI company. So the company will obviously ask for the training institutes. All the companies will ask for training institutes. Give your best student. So all the companies in nearby, right? All the companies are associated with VLSI Guru. So whenever a company requires a candidate, they will contact VLSI Guru. So past 1 year or past 2 years, who are the companies approached? If you want a list, then you please message.
Hello. Sir, recorded session will be available after every class and lab.
Yes, record session is available, and you have a portal called as InSkill portal. All right, in the InSkill portal, for every student there will be username and password. So in this, for every class, you will be getting record session that will be available for next 15 days. For every student, this will be given. This InSkill portal will be given from VLSI Guru. It like this. Like this, you will be having InSkill portal. So you can see, for example, um, physical designer. This is my. It is not any student, right? This is my portal. You will be getting videos like this. All right. The current lab, whichever is covered, right? You will be getting videos of that. In this, you will be having assignments, right? Present. See, this is my portal. For that reason, I don't have any assignments. With student portal, you'll be having assignments, you'll be having notes, a presentation. So everything will be there. Even you can go through the syllabus of physical design here. So go through the online learning or so here, right? Curriculum you can click. So you have all the information here. PD basics, semiconductor device fundamentals means PD basics, Linux, right? Advanced digital design, right? TCL scripting, synthesis. All these are syllabus which we are covering. It includes both basics and advanced part. So if you click on this, right, for example, floor plan. If you click on this, what is covered in floor plan? Right, what is covered in placement? If you click on this, right, what is covered in placement? What is covered in power planning? So what you have to use, right, inskills.in. Go to inskills.in. So what you do is in Google, you type inskills.in. Right. So in this, you will not you are not able to log in unless and until you join the course. But
Sir,
just you can go with online learning.
for STA, there is a separate
Then
course.
you can go. What ma?
For STA, there is a separate course.
STA and synthesis. STA is covered in physical design. It is part of physical design.
Okay.
STA can be taken a separate course. Only STA will be covered. It's not that STA is not covered in physical design. STA is covered in physical design. If the student is already working in physical design and if he is not sure about STA, some other student, if he is not good in concepts of STA, they can take separate course as STA. So we have also small courses like STA, like synthesis, separate course again. If you want to take, if the student is already working in a few domain and they tell that I don't want complete physical design, I want only STA. I want to go only the concepts of STA. For them, it is a separate course. But STA is already covered in physical design. So go to online, go to VLSI backend, right? Online VLSI backend courses, physical design. Here you can go with demo video, course video, and you have curriculum here. So in curriculum, you can go through curriculum model syllabus covered, right? You can go through the syllabus, and here you can see the demo video. Earlier, it old demo video. It is not my demo video. What I've done, earlier demo video. So how much hour each and every topic is taken? They have given how much hours each topic is taken. They have given the timing.
Sir, you
Yes,
said
tell
two
me.
projects. You said two projects will be covered. So that project will be same for all the batches, or it will vary. And which are the projects? What kind of project
It will
that
be
will be?
same. All the budget will be same. See, projects we have to get from the institutes, right? We have to get from synopsis. Synopsis only should give the projects because we cannot get the projects from Foundry because we have not done any MO with Foundry. If you've done MO with Foundry, we have to pay in crores. So we will not get files from Foundry. So Foundry will give files to the synopsis. What are the synopsis is giving the projects, right? That projects only we can use. So synopsis has now released two projects on 14 nm and 28 nm. So we are using the same projects. See, complex projects are two projects. Apart from that, small projects, if you want to work, you can work n number of projects. You can write your own RTL code if you are good in RTL, or you can download some RTL code from the website. You can do physical design for that. Synthesis will teach you how to do synthesis and do physical design. It's up to you. You can do n number of projects in that. Complex project, we will do only two projects.
Which will be that two complex project? I mean, that will be block. Which kind of block it will be?
So the block complexity is right. You have like 50K cells, 50,000 cells, 40 macros, right? And you have 6 clocks in that. It's a multi-voltage design. It is a design of right 32-bit RISC core processor with memory blocks along with PCI controller block. So one more project is right. So design of STDDR controller block which is having 65K cells and 50 macros with the same 8 clocks. These are the two projects which you're working on. One project will be done along with the mentor. One project will be given to you to do. You can do that.
Thank you, sir.
Thank you. Okay, then thank you. We'll wind up. Any questions from offline?
Sir, regarding the fees, you said some person will be connecting.
I think they are busy with the other session. So I've given the number right here. You can mention, you can message to this number, WhatsApp number. You can message. They will give you all the details. Whatever queries you can message to this number. Technical content even you can message to me also. I've given my number. Any technical information you want, like other information like who will be the trainer, who will be the what will be the fee structure, when the session starts, when it ends, what is the duration, right? Everything you can message to this number, manager number. Non-technical content. They will. So fees I cannot tell now, right? Because I don't know what is the fee structure they are maintaining, right? So you just message to this number. So they will give you the fee structure. What is the fee structure? It's different fees. Like if you are opting for basics, right? It's different fees. If you are opting only for advanced, different fees. Along with basic, different fees. So that please message to this. They'll give you the exact structure about the fees. So after the class, the recorded videos will be given to everyone. Even this, if you want, if the demo video will be given to you. So if you request for demo video, they'll even give the demo video. Similarly, how they are giving the videos now, after the classes, every class they will give you the video, even from the basics. So video will be uploaded tomorrow. If the class is done today, video will be uploaded either in the evening or it is done tomorrow. Get the video.
Sir, will there be doubt clearing sessions?
No, I didn't understand what is you're asking. Like for demo video you're asking?
No, sir. For I am asking like for in a week or something like that. Will we have the doubt clearing session?
Session will be a live session, right? It will be a live session. How we are
Okay.
interacting now, the session will be a live session. You can interact with the trainer. You can, if you have doubts, you can discuss there only. Or else, if you don't have doubts, right, you will be, see, every individual student will be given with one WhatsApp group. When you join to the
Okay.
institute, every individual student will be given with one WhatsApp group. So in that group, the owner of the institute, right, and admin and the trainer, everyone will be present, right? So what you can do is you can post whatever queries present, whatever queries you have. For example, digital is done and trainer is different, but you have doubt in digital. But already you are moved to what? TCL, trainer is different. For example, you assume. So you want to discuss questions related to digital. Because if you have doubts during the digital classes, it's fine. Because trainer is available, every day is available, he is taking the classes. But now it is already done. Digital is already done. Then what you can do is you can post your doubt in that group. Right? You can post the doubt in the group. So if you post the doubt in the group, they will add the required trainer in that group and he will respond to your query. And after the course, every course, if you have any doubts, you can request for doubt clarification session, it will be done. So there is an the institute will never think to do one more session as a doubt clarification session. If you have doubts, 100% they will do doubt clarification session immediately after the session. If session is completed, it's already done after, if you have doubts after 15 days or 20 days, then what you can do is you can post your message in the group. If for every person there will be individual WhatsApp group. not in the main group. Every person will be in the main group. For every person, there will be individual WhatsApp group. In that, you will be there along with the office staff, trainer, and owner will be there. So you can ask the query, and the trainer will respond to that. If you have doubts
Okay, sir.
after
Thank
15
you.
days, yes, sir. Thank you.